Alaska stretches endlessly, a place where the ordinary can suddenly feel uncanny. Mist rolls over jagged peaks. Waters hide movements unseen. And the skies shimmer with secrets that vanish as quickly as they appear. Strange sounds echo across frozen valleys, and shifting landscapes defy understanding. In this land of extremes, nature and the unknown seem to collide, leaving traces that puzzle even the sharpest minds. In this video, we'll explore some of the most baffling and mysterious phenomena that continue to elude scientific explanation. Here, the unexpected waits around every corner, and every shadow and flicker holds a story that science cannot fully explain. The bloop, an unidentified underwater sound. In the summer of 1997, scientists monitoring the deep Pacific Ocean recorded a sound unlike anything they had ever encountered. The noise was incredibly powerful, traveling for thousands of miles underwater, and it carried a low frequency that seemed to vibrate through the water itself. Researchers at the National Oceanic and Atmospheric Administration, or NOAA, were the first to analyze the recording. They called the sound the bloop, a name that hinted at its strange sudden burst and the way it seemed to echo across the ocean depths. The sound was detected in the South Pacific, near the coordinates of 50 south and 100 west, far from the coasts of any major landmass. It was so strong that it registered on multiple sensors hundreds of miles apart, making scientists question whether it came from a single source or a massive unknown phenomenon. The bloop's frequency suggested something immense, far larger than the blue whale, the largest creature known to inhabit the ocean. Unlike familiar whale calls, which vary in pitch and length, the bloop maintained a strange rhythmic consistency, rising and falling in a way that made researchers think it might come from something alive. Yet, unlike any species cataloged in scientific literature, NOAA specialists ran endless comparisons against known animal sounds. They listened to recordings of whales, giant squids, and even the loud snaps of undersea ice cracking. Every possible match failed. Some researchers began to wonder if the bloop might be geological in origin, perhaps caused by ice quakes or shifting tectonic plates. Yet, the location of the recording did not match typical areas of ice activity, and the signal moved in a way inconsistent with a simple underwater fracture. Its sudden bursts and the distances over which it could be detected created an enigma that even the most experienced oceanographers could not explain. The bloop drew attention not just from scientists, but from the public and media. The mysterious nature of the sound led to speculation in newspapers, magazines, and early internet forums, where some suggested the sound might come from a massive unknown sea creature. Popular culture quickly dubbed it a monster of the deep, a kind of real-life kraken. Though scientists themselves were careful to avoid unsubstantiated claims, researchers emphasized that while the sound hinted at something unusual, there was no evidence linking it to any living organism. In the months following the discovery, further recordings of the bloop were analyzed. The sound was traced back to a general region of the Pacific known for its deep trenches and complex underwater ridges. These areas are difficult to explore, even with modern submersibles, because of extreme pressure and darkness. While some attempted to send underwater vehicles to investigate, the exact source could not be located. The ocean floor at that latitude is rugged and remote, filled with canyons and seamounts that could potentially generate unusual noises. But none matched the signature of the bloop. Oceanographers noted that the bloop's characteristics resembled vocalizations from large marine animals, but there were notable differences. It had a lower pitch than the calls of the blue whale and a faster modulation than typical whale songs. Some experts suggested it might come from a species of giant squid, though no specimen has ever been found that could produce a sound so powerful. The ocean remains largely unexplored, and with nearly 80% still unmapped, it is possible that enormous mysterious organisms still lurk in the darkness. Technological limitations also made it difficult to investigate. The hydrophones that recorded the bloop were part of a system designed to monitor undersea activity, mainly to detect earthquakes or submarine events. These instruments were sensitive to unusual vibrations, but could not reveal the exact source or nature of the sound. Even when multiple sensors picked up the noise, triangulating its origin proved challenging due to the way sound travels through varying temperatures and densities in the ocean. Each attempt to pinpoint the bloop led to more questions rather than answers, deepening the mystery. Even decades later, the bloop continues to intrigue scientists and enthusiasts alike. The sound still lingers as a reminder that much of the ocean remains unknown, and perhaps something vast still waits in the dark. The golden eggs of the Gulf. Music. In recent years, deep-sea expeditions in the Gulf of Alaska have revealed something that left both scientists and the public stunned while exploring the ocean floor with submersible vehicles. Researchers stumbled upon clusters of strange golden spheres resting on the seabed. These orbs were smooth, glimmering under the artificial lights of the cameras and scattered across the dark silt like treasures hidden in the depths. Their unusual appearance earned them the name golden eggs, though their origin and purpose remain completely unknown. The discovery was first documented by teams working with the National Oceanic and Atmospheric Administration. In 2016, during the Okeanos Explorer mission, a remotely operated vehicle captured clear footage of one of these golden objects at a depth of more than 2 miles below the surface. The sphere appeared to be soft with a delicate skin that could be punctured, yet it maintained a near-perfect round shape. Scientists speculated in real time, their voices recorded over the live feed, wondering if they were looking at an egg sac, a casing, or something entirely alien to marine biology. The possibility that these spheres could be biological raised even more questions. If they were eggs, what creature had laid them in such a hostile environment, far from sunlight and in crushing pressure? No marine animal known to science produces eggs of this size or color, especially in such depths. Some researchers suggested they might be related to sponges or corals, organisms that often leave behind unusual skeletal structures. Yet, the smooth, almost polished surface of the golden eggs did not resemble any coral formations previously cataloged, leaving experts without a clear comparison. Samples were collected during these expeditions, using the mechanical arms of the remotely operated vehicle. The researchers carefully retrieved one of the spheres, sealing it in a sterile container to bring it back to the surface. Once analyzed, the results added to the mystery. The outer layer was organic, similar in texture to tissue, but the inner composition was harder to classify. Some areas appeared hollow, while others contained fibrous material, as though the object had once supported growth or was in the process of forming something. Despite careful study, no clear DNA match was made, leaving scientists unable to identify the origin of the material. The golden eggs sparked debate among marine biologists around the world. Some proposed they were remnants of an unknown deep-sea species, perhaps related to invertebrates yet to be documented. Others argued that they could be mineral deposits shaped by rare geological processes, though this theory struggled to explain the delicate organic qualities of the spheres. The sheer number of them spread across multiple sites also suggested that they were not random anomalies, but part of a larger pattern. One unsettling aspect of the discovery was the way the spheres appeared in clusters. In some places, dozens of them were grouped as though placed deliberately or produced in batches. This raised the question of whether the golden eggs were actively created by a living organism, perhaps as part of a reproductive cycle, or if they were naturally forming structures linked to deep-sea chemistry. The Gulf of Alaska's waters are home to hydrothermal vents and unusual geological ridges. But no known process in these environments has been observed producing anything like the golden orbs. The imagery of the discovery spread widely online, with viewers commenting on how artificial the spheres looked. Their symmetry, color, and even their placement in lines or patterns on the seafloor led some to speculate about non-biological origins. While scientists avoided jumping to conclusions, the resemblance to manufactured objects was difficult to ignore. Questions began to circulate about whether the spheres might be remnants of human activity, though their location in untouched remote areas of the Gulf made that unlikely. Further expeditions have continued to search for more samples, but the mystery persists. The orbs seem to appear in isolated locations, and their fragility makes them difficult to collect intact. In some instances, they crumble or collapse when disturbed, complicating the ability to study them in laboratories. With every failed attempt to classify them, the sense grows that the ocean floor still holds secrets beyond current scientific reach. Resting quietly on the seafloor, the golden eggs of the Gulf remain unexplained, hinting at something still hidden in the dark. Savanowski Crater, a geological puzzle. Tucked deep within the rugged landscapes of Alaska's Charmy region lies a feature that has defied easy explanation for decades. Known as the Savanowski Crater, it is a large symmetrical depression in the Earth that does not fit neatly into any geological category. At first glance, it looks like a classic volcanic caldera, but closer study reveals inconsistencies that continue to puzzle scientists. The crater's striking round shape suggests a violent impact or eruption, yet neither theory fully explains its formation. The area around Savanowski is no stranger to geological activity. The region was devastated in 1912 by the eruption of Nova Rupta, the largest volcanic eruption of the 20th century. That event blanketed the area in ash and gave birth to the Valley of 10,000 Smokes. With such a dramatic backdrop, it is easy to assume that the Savanowski crater is volcanic in origin. However, when geologists began investigating, they found a lack of evidence for a direct volcanic explosion at the site. Lava flows, ash deposits, and venting structures that normally accompany such features were missing, leaving researchers without the usual clues. Because of its size and perfectly rounded outline, another theory quickly emerged. Some scientists proposed that the Savanowski crater might have been formed by the impact of a meteorite. Alaska, like many northern regions, is known for its exposure to meteors and comets, and the force of such an event could have easily carved a crater of that magnitude. Yet, when soil and rock samples were studied, researchers could not find the traces typically left behind by an extraterrestrial strike. There were no layers of shocked quartz, no fragments of meteorite, and no distinct chemical signatures that would confirm a celestial origin. This dual mystery, balanced between volcanic and meteoric explanations, has left the Savanowski crater in a unique scientific limbo. Volcanologists argue that its location in a geologically active region supports a volcanic explanation, even if the evidence is incomplete. At the same time, planetary scientists point to its perfect symmetry as something far more consistent with an impact. Neither side has been able to provide definitive proof, and each expedition to the crater brings back more questions than answers. The history of the surrounding area adds to the intrigue. Savanowski was once a village near the Naknek Lake area, inhabited by indigenous people before the 1912 eruption forced its abandonment. Oral traditions from native Alaskans sometimes reference strange rumblings and changes in the land, long before modern geological surveys took place. These accounts, while not always specific, suggest that the crater may have held significance and mystery even before it caught the attention of scientists. Whether these stories relate to the crater's origin or simply to the violent volcanic history of Charmy is difficult to determine, but they contribute to its aura of uncertainty. In recent decades, technological advances have allowed researchers to map the crater in greater detail. Remote sensing and aerial surveys have shown that the depression is remarkably consistent in shape, with steep walls and a depth. That suggests enormous energy was involved in its creation. Despite these findings, no clear volcanic vent has been located. Similarly, while satellite imagery has been useful in identifying impact craters around the world, none of the usual hallmarks, such as a central uplift or surrounding ring fractures, have been confirmed at Savanowski. What makes the mystery even deeper is the crater's isolation. Unlike famous volcanic calderas, such as Crater Lake in Oregon or the Yellowstone caldera in Wyoming, Savanowski does not sit within a well-documented chain of eruptive events. Nor does it align with known meteorite impact fields in Alaska. It exists as a solitary feature carved into the landscape, without clear ties to any broader pattern. This lack of connection frustrates attempts at classification, leaving it stranded between competing theories. Some modern researchers have floated alternative explanations, including the possibility of a massive underground gas explosion or the collapse of a hidden magma chamber. These ideas, while imaginative, remain speculative because no direct evidence has been found to support them. The sheer remoteness of the region makes fieldwork difficult, and each trip requires extensive preparation and resources. The harsh conditions of Alaska's wilderness often cut studies short, meaning that much of what is known comes from limited surveys rather than exhaustive exploration. Savanowski Crater still waits in silence, its perfect walls and empty floor holding on to the story of how it came to be. The singing sands of Alaska. Far from the noise of cities and the movement of highways, there are stretches of beach in Alaska where the silence is broken by a sound few expect to hear from sand. Visitors describe it as a low, vibrating hum, sometimes compared to the drone of a distant organ or the echo of a bass string. These beaches, scattered in places like Lituya Bay and Bristol Bay, have been called the Singing Sands. And the strange voices that rise from their grains remain one of the state's most unusual mysteries. What makes the sound so unsettling is how alive it feels. When a person walks across certain slopes of dry sand, the motion sets off a deep vibration that rolls beneath their feet as if the ground itself is breathing. Other times, the sound comes when strong winds sweep across the beach, causing dunes and ridges to tremble with a long, drawn-out tone. Local fishermen have said the noise sometimes carries across the water on still nights, a haunting echo that seems to come from nowhere in particular. Scientists have studied singing sands in other parts of the world, from the deserts of China to the dunes of Death Valley in California. Yet Alaska's examples remain harder to explain. In warm desert regions, the singing often occurs when dry grains of sand slide down a dune, creating a synchronized vibration. But on Alaska's cold and often wet coasts, the same process does not fit so neatly. The air is damp, the sand is mixed with silt and broken shells, and the climate does not match what researchers usually associate with Singing Dunes. In 1905, explorers passing through Lituya Bay reported hearing the strange tones as they crossed a stretch of beach after a storm. They described it as a sound like far-off church bells, deep and mournful, and without any clear source. Later accounts from the 1930s in Bristol Bay mentioned hunters pausing in the middle of their trek because the ground beneath them seemed to sing as their boots pressed into the sand. For some, the experience was so strange that they avoided those areas entirely, fearing it was a warning. Locals have woven the phenomenon into their own stories. Among the Yupi people of western Alaska, some elders tell of spirits that move through the sands. Their voices carried upward when the wind disturbs the earth. These tales give the beaches an aura of caution, where travelers are reminded that even the land itself can speak if one listens closely enough. Such stories pass through generations, mixing cultural memory with the unexplained hum of the dunes. Modern geologists have suggested that Alaska's singing sounds might come from unusually round and uniform grains, which, when disturbed, can slip against each other in perfect rhythm, creating vibrations strong enough to be heard. Others argue that the presence of frozen ground beneath certain beaches may amplify the sound, turning small movements into resonant echoes. Yet, every time a new explanation is put forward, other researchers point out gaps that cannot be filled so easily. Why do some stretches of beach sing while others, just a few miles away with nearly identical sand, remain silent? Why do the sounds sometimes vanish for years at a time, only to return suddenly after storms or changes in the tide? Field recordings from the 1960s captured these sounds in Lituya Bay during a particularly dry summer, and the tapes reveal a deep, vibrating tone lasting several seconds. Listening to them today, one might mistake the sound for machinery hidden just below the surface or the distant hum of a ship engine. But no machines were present, only waves, wind, and sand. The mystery continues to draw attention from curious travelers. Some arrive hoping to hear the sounds for themselves, pressing their boots into the ridges of a remote beach, waiting for the ground to hum beneath them. Others set up microphones, attempting to capture the tones in a way that could finally explain the mechanics behind the sound. But many return with only silence, finding that the beaches keep their voices hidden unless the exact conditions align. To this moment, the sounds of Alaska do not always reveal their song, and when they do, the tones rise and fade as if the land itself is whispering secrets meant to remain unanswered. The mystery of underwater pockmarks. Beneath the waters of Alaska's continental shelf lie patterns that look as though the seafloor has been punched again and again by some unseen hand. These formations, known as pockmarks, stretch for miles across the ocean floor. Each one is circular, often tens of meters wide and several meters deep, creating a strange and almost unnatural landscape. From above, they appear like clusters of craters on the moon. Yet, they are hidden far beneath the surface where only sonar can reveal them. The first detailed surveys of Alaska's underwater pockmarks were carried out in the 1970s when research vessels mapping the Beirut Sea noticed fields of depressions unlike anything they expected to find. Scientists at the time suspected they might be related to methane escaping from the seabed, since gas bubbles can sometimes leave behind cavities. However, the size and number of the marks did not fit the normal patterns of gas release. Instead of being scattered at random, many of them formed neat rows and sweeping curves, as if they had been carved with intention. Over the years, similar discoveries have been made in enough to disrupt sensitive equipment, and yet they do not appear to follow a simple or predictable pattern. The problem is made worse by the remoteness of the islands. Harsh weather and turbulent seas limit the time researchers can spend collecting reliable data, and many sections of the chain remain poorly measured compared to other parts of the Pacific. For those at sea, the anomalies can be unnerving. Fishermen from Dutch Harbor have told of navigation systems that suddenly place their vessels miles from their actual location, forcing crews to rely on experience and instinct to find their bearings again. Some describe sonar systems that refuse to return a proper reading when crossing certain areas, as though the ocean itself has swallowed the signals. In a place where fog can roll in thick and fast, erasing the horizon, these invisible distortions add a layer of danger that only those who live with them truly understand. The aviation world has faced similar risks. In 1943, during the Battle of O, American pilots reported unusual compass behavior that complicated their missions in an already hostile environment. Even decades later, with the advent of GPS, the anomalies have not fully lost their grip. GPS signals can be interrupted by ionospheric disturbances, that are especially strong at high latitudes, and when combined with the irregular magnetic fields of the illusions, pilots sometimes find their instruments giving contradictory information. For those flying long routes over open ocean, trust in technology becomes fragile when the invisible landscape refuses to stay steady. Modern researchers continue to study the illusion anomalies, hoping to untangle their causes. Teams from the University of Alaska Fairbanks and the Scripps Institution of Oceanography have suggested that shifting magma beneath the crust may generate temporary changes in magnetic intensity, while others argue that remnants of ancient crust buried below the seafloor still carry magnetic signatures that confuse modern instruments. Whatever the explanation, the effect remains a constant challenge for both science and navigation. A reminder that our grasp of the planet's magnetic forces is far from complete. Those who cross the chain often wonder if the shifting needles and silent glitches are just quirks of geology, or signs that the illusions hold a deeper secret still waiting to be uncovered. The vanishing aurora events. On a cold winter night in Alaska, people often step outside to watch the aurora borealis. Curtains of green, pink, and violet dance across the sky, shifting and glowing as charged particles collide with Earth's atmosphere. Yet among the many breathtaking displays that have been recorded, there are also strange reports of the light suddenly vanishing, almost as if someone had flipped a switch. These abrupt disappearances are not explained by normal scientific understanding, and they have become one of the most puzzling mysteries tied to Alaska's skies. The phenomenon has been observed by scientists and locals alike. In 2002, researchers at the Poker Flat Research Range north of Fairbanks tracked a sudden collapse of auroral activity during what had been a strong geomagnetic storm. The lights faded in less than a minute, leaving a strangely empty sky. For experts who monitor auroras daily, such a sharp cutoff did not fit into the usual patterns they expected. Instead of a gradual decline, the event ended almost instantly, raising questions about whether something more complex was at play. During that same year, scientists using instruments at the Geophysical Institute in Fairbanks recorded unusual drops in electron precipitation that coincided with the fading lights, but they could not determine what triggered the sudden cutoff. Locals tell stories of similar vanishings, recalling how the skies above villages like Utki or Nome would fill with light and then go completely dark without warning. Hunters and travelers who rely on the glow of the aurora for navigation in remote areas sometimes describe the sudden blackness as disorienting, even frightening. Their accounts align with scientific data showing gaps in auroral activity that cannot be traced to shifts in the solar wind or Earth's magnetic field. These real experiences keep the puzzle alive outside of laboratories and observatories. Scientists who study the magnetosphere have suggested several possible explanations. One idea is that rapid shifts in electrical currents high above Earth's surface may cause the lights to collapse suddenly, though the speed of the change remains difficult to explain. Another possibility is that certain particles in the atmosphere lose energy more quickly than expected, cutting off the glow all at once. Yet, these are working theories, and none have been proven with certainty, leaving researchers cautious about drawing firm conclusions. The mystery is deepened by how selective these vanishings can be. Sometimes one part of the sky will go dark while another section, just miles away, continues to shimmer. At times the phenomenon seems to ripple outward like a wave of absence, erasing color from one horizon to the next. The patchwork nature of these disappearances makes them harder to study, since instruments on the ground often capture only part of the event, while the rest unfolds beyond their reach. Adding to the intrigue, satellite images taken during some of these vanishings do not always match the ground-based reports. There are cases where space-based sensors still detected auroral energy, even as people standing under the sky saw nothing at all. This gap between what is recorded from orbit and what is visible on Earth raises questions about how auroras interact with the atmosphere and weather. Certain conditions can cloak the lights from human sight. The possibility that auroras can exist unseen, hidden just beyond our vision, is both unsettling and fascinating. In 2019, this mission observed a brief disappearance over Alaska that lasted only 40 seconds. A finding that highlighted how little time scientists sometimes have to capture the full process. For the scientific community, vanishing auroras are more than a curiosity. They reveal gaps in our knowledge of space weather and how Earth interacts with the sun. Predicting auroral activity is important not only for those who watch the skies, but also for aviation, satellite operations, and even power grids. If sudden disappearances can occur without warning, they suggest that there are forces in the magnetosphere still unaccounted for, forces that may have consequences far beyond the glow of the northern lights. What makes the vanishing so haunting is their unpredictability. They strike without pattern, erasing beauty from the sky and leaving behind only questions, as though the night itself is capable of hiding secrets when it chooses. The abyssal shadows of the Gulf of Alaska. Beneath the cold waters of the Gulf of Alaska, far beyond the reach of divers and fishermen, sonar scans have revealed something that unsettles even seasoned oceanographers. At great depths, where pressure crushes steel and sunlight cannot reach, enormous shadow-like shapes move slowly across the ocean floor, sometimes appearing on monitors for only moments before fading into the black. The phenomenon is now referred to as the abyssal shadows, and it is one of the Gulf's most troubling mysteries. The first notable encounter was in 1972, when a research ship mapping the seafloor for geological studies detected a cluster of moving anomalies west of Kodiak Island. At first, the crew suspected submarine activity, but the objects were far too large and deep to match known technology. Some of the shadows stretched for hundreds of feet with outlines that suggested bulk and form rather than mere clouds of sediment. When the scans were repeated minutes later, the shapes had vanished, leaving a flat seafloor behind. Over the following decades, similar reports surfaced, many from ships working under NOAA or conducting academic research. In 1998, a University of Alaska expedition reported a large mass rising from the seabed before disappearing into deeper water, an event witnessed both on sonar screens and in the acoustic signatures collected during the survey. The team could not agree whether it was a geological feature shifting under pressure or some kind of massive biological presence. Marine biologists were quick to suggest that giant schools of fish or large gatherings of squid could create illusions on sonar. Yet, the abyssal shadows behave differently from known animal groups because they appear solid, move slowly, and sometimes hold their shape for minutes at a time. Shows of fish scatter and regroup, leaving familiar patterns that can be measured and predicted. The shadows do not. Instead, they drift as if self-contained, unbothered by currents, sometimes splitting apart or merging before slipping back into the abyss. Attempts to capture visual proof have proven nearly impossible. Remotely operated vehicles sent into the regions where shadows were last recorded often return with nothing but static or murky water. In 2011, a camera mounted on a deep-sea probe briefly recorded a faint massive form moving past the lens, blotting out the dim light. But the footage was too blurred to analyze. Scientists who reviewed the video noted that the object appeared to block light rather than reflect it, an oddity that suggested mass, but not an identifiable structure. There are also technical puzzles to consider. In some cases, the appearance of abyssal shadows is accompanied by short bursts of interference in acoustic instruments, as though the equipment is being disrupted by something more than simple movement in the water. Crews have described their sonar screens freezing or glitching for seconds at a time, only to resume normal operation once the shadow vanishes. Some geologists have speculated that these could be caused by shifting undersea ridges or sudden bursts of methane seeping from the ocean floor. Methane releases can indeed cause bubbles large enough to distort sonar readings, but they do not move with the slow, deliberate patterns described by observers. Others suggest that unknown currents or deep-sea vortices might distort sonar waves in unusual ways. Still, such theories do not explain why multiple ships decades apart in different conditions all report nearly identical encounters. What makes the abyssal shadows especially unnerving is the sheer size implied by the data. Many shapes are larger than commercial aircraft, some even rivaling small islands in apparent volume. If they are living organisms, they would represent forms of life unlike anything previously documented in Earth's oceans. If they are not biological, then they may represent geological or physical phenomena that science has yet to recognize. Either option unsettles the boundaries of current knowledge. Fishermen who work near the Gulf sometimes speak of unexplained, quiet zones where sonar goes blank and catches disappear as though the sea itself has gone empty. These local accounts echo the official reports, though they are harder to verify. Still, the persistence of the stories suggests that the abyssal shadows are not rare, but simply remain hidden most of the time in places where few humans dare to go. Ships that cross the Gulf today continue to send back puzzling readings, strange patterns that flash across the screens before returning to normal as if nothing had ever happened. And somewhere beneath that cold, heavy water, the vast shadows drift on, keeping their nature concealed in the dark. The shimmering fog of Prince William Sound. Prince William Sound is a place where the sea often hides itself behind curtains of fog, a familiar sight to anyone who has sailed its waters. Yet among the ordinary blankets of mist, sailors and fishermen have long spoken of a strange version unlike any other. A fog that seems to shimmer with light as if tiny sparks are caught inside it. This phenomenon, rare and unpredictable, has been recorded for more than a century and remains one of the most unsettling mysteries of Alaska's coastal waters. Reports of the shimmering fog stretch back to the late 1800s when fishing crews described glowing patches rolling in from the open sound, spreading over the decks of their boats and then dissolving into the night. The glow was not steady like moonlight, but moved in restless streaks, shifting in brightness as if alive. The earliest written account dates to 1895, when a trader named Thomas Larkin recorded in his journal that his vessel was surrounded by fog, filled with wandering lights that made his crew refuse to leave their posts until morning. Modern accounts show that the stories did not fade with time. In 1967, a Coast Guard vessel stationed near Valdez reported a strange fog bank that glowed green and white, with the lights flickering as if they were being carried inside the mist. The officers noted that no other ships or beacons were nearby, and the lights did not match the behavior of bioluminescent plankton. Instruments on board recorded no anomalies in the water or sky, yet the fog shimmered for nearly half an hour before drifting apart. The report was filed, but never explained. Scientists have tried to suggest possible causes. Some believe the fog may be reflecting distant auroral activity, since the northern lights are common in Alaska. However, aurora displays appear in the upper atmosphere, not within ground-level fog, and the lights described often occur when the sky above is clear of auroras. Others argue that bioluminescent organisms stirred into the air by waves or wind might create the glow. But fog banks form from condensed water vapor, not airborne plankton. The mismatch leaves researchers with theories that do not quite fit the evidence. Local fishermen add another layer to the story, claiming the shimmering fog is sometimes accompanied by strange sounds, They speak of faint humming like a low electrical buzz or whispers carried on the mist. In 1983, a group of crab fishermen near Hinchinbrook Island reported that their radios filled with static as the glowing fog enveloped their boat. The interference ended as soon as the mist dispersed, leading some to wonder if the phenomenon might be linked to electromagnetic activity. Attempts to study the shimmering fog directly have been few, largely because of its unpredictable nature. The sound covers nearly 10,000 square miles of water with shifting weather that makes systematic observation difficult. Researchers from the University of Alaska, Fairbanks attempted to monitor fog conditions in the area in the 1990s, but none of their expeditions coincided with the glowing events. Without reliable sightings, gathering hard data has proven almost impossible. There are also safety concerns. Mariners who encounter the fog often describe a sharp drop in visibility, making navigation through the narrow channels of the sound dangerous. Combined with the unsettling glow and occasional interference with instruments, many crews prefer to avoid travel when the fog appears. This reluctance adds to the scarcity of first-hand scientific observation, leaving most information to second-hand accounts and scattered reports. Still, the stories continue to surface. In 2014, a kayaker near Weir claimed he watched a bank of glowing mist drift silently across the water just after midnight. He described it as filled with shifting strands of light like threads of silver weaving through the fog. His photograph showed nothing unusual, but he insisted the glow was visible to the naked eye. Similar accounts from locals suggest that the phenomenon remains part of the hidden character of Prince William Sound, appearing only to those who happen to be in the right place at the right time. The shimmering fog continues to drift across Prince William Sound, its shifting lights hinting at secrets no one has yet glimpsed. The underwater lights of the Bering Sea. The waters of the Bering Sea are known for their harsh conditions with fierce storms and freezing temperatures that challenge even the most experienced crews. Yet beneath the surface, there is a phenomenon that has left marine scientists puzzled for decades. Bright moving lights deep underwater that seem to have no source. These lights are not bioluminescent creatures as commonly known, nor are they reflections from the surface. They appear in patterns and movements that defy explanation, as if something intelligent or unknown is guiding them across the ocean floor. One of the earliest reports came in 1979, when a team of NOAA researchers conducting deep-sea surveys recorded unusual flashes of light at depths of over 1,200 m. The instruments picked up bright pulsating lights that moved slowly across the ocean floor, then disappeared entirely. The researchers were baffled because the movements did not match any known underwater species or natural phenomena. Subsequent dives to the same area revealed nothing, leaving the light's origin a complete mystery. In the 1990s, further sightings were documented by Soviet and American naval crews conducting sonar mapping of the region. The lights would often appear in clusters, sometimes stretching hundreds of feet apart, and would shift position in ways that did not align with water currents or geological activity. Scientists initially suspected unusual chemical reactions from the seabed, but water samples showed nothing abnormal. These lights seemed to exist independently, moving with a will of their own in the cold, dark depths. Fishermen and local elite communities have long spoken of the lights in hushed tones, describing them as glowing orbs that rise from the depths before vanishing into the blackness. One account from 2003 details a commercial crabboat crew who watched a series of lights moving rhythmically beneath the waves for nearly 10 minutes. The crew tried to follow the lights with submersible cameras, but every time the camera approached, the lights would dart away or vanish entirely. Such behavior added to the idea that the phenomenon could be intelligent, Though no proof exists, scientists have proposed several theories to explain the underwater lights. Some suggest that unusual mineral deposits might refract light in rare ways, producing brief glows. Others believe that unknown deep-sea creatures with extraordinary bioluminescent abilities could be responsible. Still, none of these explanations fully account for the precise patterns and coordinated movements observed. The lights often appear in sequences that suggest intention rather than random motion. In 2007, a Russian research vessel recorded the lights emitting short bursts of different colors, including blue and amber, an observation that further puzzled scientists because no known deep-sea species produces such varied bioluminescence. In 2012, an expedition by the National Oceanic and Atmospheric Administration used advanced remotely operated vehicles equipped with high-sensitivity cameras and sonar to investigate the phenomenon. The crew reported seeing faint moving illuminations that responded to the movement of their submersible. The lights appeared to avoid the vehicle, retreating into darker areas before returning once it moved away. Researchers were left with more questions than answers, as the behavior did not match any known marine life or geological effect. Adding to the mystery, some sonar readings have suggested the lights exist at different depths simultaneously, as if multiple layers of glowing forms are traveling independently. This makes the phenomenon difficult to study systematically, because instruments often capture only a fraction of the activity. Some theorists even propose that electromagnetic anomalies could be causing visual effects in instruments or human perception, though no consistent evidence has been found to support this. Certain locations in the coastline and shifting tundra, researchers occasionally visit the site, hoping new technology might uncover hidden clues. Yet, each expedition returns with more questions than answers. Whatever force claimed Notkovich seems to have left no indication that it will reveal itself again. The unidentified bioluminescent creatures of the Gulf. The Gulf of Alaska is home to some of the most remote and unexplored stretches of ocean on Earth. Its deep waters, often hidden beneath thick fog and pounding waves, have long fascinated marine scientists. Yet, despite decades of study, some of the Gulf's inhabitants continue to defy explanation. Among the most puzzling are the strange bioluminescent creatures first observed in the 1990s, glowing in coordinated patterns unlike anything documented in known marine life. The first formal sightings came during a 1994 expedition led by researchers from the University of Alaska Fairbanks. Using deep-sea submersibles equipped with low-light cameras, they observed small glowing organisms moving together in synchronized formations, almost as if performing an underwater ballet. The scientists noted that the creatures' light pulses varied in color and intensity, shifting from blue to green to faint amber. This behavior was unlike that of typical bioluminescent species, which usually emit a single consistent glow for communication or predation. Reports from local fishermen soon corroborated the scientists' observations. Crew members on long lines and crabboats described seeing strands of glowing shapes rising from the depths, twisting and weaving around one another. One fisherman recalled, "It looked like the ocean had come alive with tiny lanterns all moving in time like they were aware of each other." Such first-hand accounts were rare, but they added credibility to the idea that something unusual was occurring far below the surface. In 2001, a deep ocean survey using autonomous underwater vehicles recorded clusters of these glowing organisms at depths exceeding 1,500 meters. The vehicle sensors detected coordinated light pulses that seemed to travel in waves across the water, moving faster than any known group of bioluminescent creatures. Even stranger, sonar readings indicated that the organisms maintain formation without any visible means of propulsion. suggesting an unknown method of movement that marine biologists have proposed several explanations. Some suggest that the creatures might represent a previously undiscovered species, capable of complex communication through light. Others theorize that the coordinated patterns could be a form of hunting behavior. Though no evidence of predation has been observed, genetic samples collected during a 2005 expedition have failed to match any known species, deepening the sense of mystery surrounding these glowing life forms. In addition to their physical and behavioral oddities, the creatures exhibit unusual environmental preferences. Unlike most deep-sea bioluminescent species, which tend to inhabit stable, nutrient-rich areas, these organisms have been found in regions with strong currents, low oxygen levels, and shifting underwater temperatures. This adaptability challenges assumptions about the ecological limits of bioluminescent life and raises questions about how they survive in such extreme conditions. Recent chemical analysis of the surrounding water revealed unusually high concentrations of rare minerals, suggesting that the creatures may derive energy or nutrition from sources unknown to science. Observations from a 2012 expedition indicated that their light pulses could reach wavelengths beyond the visible spectrum, possibly allowing communication invisible to human eyes. Additionally, some specimens appear to produce a faint electrical field, hinting at a biological mechanism for navigation or interaction that has never been documented before. Sightings are not consistent, making the creatures even harder to study. In some years, they appear in large numbers near Prince William Sound, while in others, they vanish completely. Scientists have speculated that these fluctuations may be tied to changes in ocean currents, chemical compositions, or unknown migratory patterns. Yet, despite repeated attempts to track them, the movements remain unpredictable, leaving researchers with only brief glimpses of their existence. The glowing creatures have also been observed interacting with other species in unusual ways. Some reports indicate that the light patterns appear to influence the behavior of nearby fish and squid, causing them to cluster or disperse. However, no evidence has emerged to explain why these interactions occur, or whether the creatures are intentionally affecting other species. Deep-sea photographers have occasionally captured images of the creatures in the act of forming geometric shapes, circles, and lines that almost seem intentional. These formations vanish as quickly as they appear, further challenging the understanding of their behavior. The patterns have led some researchers to consider the possibility that the creatures possess a level of collective intelligence previously unknown in marine ecosystems. The bioluminescent life in the Gulf of Alaska continues to intrigue and mystify, moving silently in the darkness with a rhythm no one has fully deciphered. The mysterious tremors of Mount Iliamna. Mount Iliamna, a massive volcano in southwestern Alaska, has long been monitored for volcanic activity. Despite its dormant appearance, seismographs in the area have recorded unusual tremors that do not match typical volcanic or tectonic patterns. These low-frequency quakes are subtle yet persistent, sometimes lasting for minutes or even hours, without causing visible shifts in the surrounding terrain. Their origin has puzzled geologists because they differ from both regular earthquake activity and volcanic rumblings, typically associated with magma movement. The first notable series of these tremors was documented in 1977, when local seismic stations detected continuous vibrations beneath the volcano. At that time, scientists expected the readings to precede minor eruptions or landslides, yet no surface activity followed. These tremors appear to emanate from deep underground in areas where traditional geological models predict solid rock, not the movement that could generate detectable vibrations. Seismologists returned to Mount Lemmon in the 1980s to study the pattern more closely. They discovered that the tremors were extremely low in frequency, producing vibrations that could travel for dozens of kilos without losing strength. Residents in nearby villages occasionally reported feeling the ground hum underfoot or hearing a deep resonant rumble. Sometimes, even during calm weather where no storms or earthquakes were reported, attempts to explain the phenomenon with magma movement proved inconclusive. Mount does have a magma chamber, but measurements of temperature and pressure suggest that the tremors originate from areas far below the active chamber. Some geologists theorize that fluid movement in hidden underground reservoirs could be causing the vibrations, yet no evidence of such reservoirs has been found. This leaves the tremors without a clear mechanical explanation. In 1995, a research team deployed advanced seismic arrays around the volcano to map the tremor patterns in 3 dimensions. Their data revealed that the tremors occurred in repeating pulses, almost as if they were generated by a rhythmic source deep within the earth. The periodic nature of the tremors defied expectations because natural quakes and volcanic activity are usually random or linked to specific stress events, not consistent cycles. Further analysis revealed that some tremors coincided with small shifts in underground water tables, suggesting a possible link between subterranean fluids and the vibrations. However, the scale and depth of these quakes make it unlikely that water alone could generate such powerful low-frequency pulses. Drone-based thermal imaging conducted in 2011 detected faint heat anomalies on the slopes of Mount Iliamna during active tremor periods. The heat patterns appeared in isolated pockets with no visible surface activity, hinting at an unknown process occurring far beneath the volcano's crust. Local folklore provides additional context for these strange vibrations. In stories passed down through generations, villagers describe the mountain as alive, occasionally groaning or humming to warn of unseen dangers. While modern science does not recognize these accounts as evidence, they do suggest that the tremors are not entirely new and may have been observed for centuries without understanding their cause. Researchers also noted unusual electromagnetic readings during periods of tremor activity. Sensitive instruments detected brief surges in the local magnetic field that corresponded with the low-frequency quakes. No known volcanic or tectonic process can fully account for these simultaneous electromagnetic disturbances, leaving scientists with more questions than answers about the mechanisms behind mountains' mysterious movements. Analysis of rock samples taken near the volcano revealed microfractures that may transmit vibrations more efficiently than normal crust, potentially amplifying the tremors. Acoustic sensors detected subtle harmonic overtones accompanying the quakes, a phenomenon rarely observed in natural seismic events. Additionally, satellite radar imagery showed minute surface bulges appearing and disappearing in sync with some tremor cycles, hinting at underground movements too small to detect by other means. Even more baffling, the tremors sometimes occur without warning and do not follow any seasonal or geological pattern. Periods of intense activity may last for days, followed by long stretches of silence. This unpredictability makes them difficult to study and challenges the assumption that all seismic activity is linked to observable geological changes. Recent magnetotelluric surveys indicate unexpected conductivity anomalies beneath the volcano, suggesting pockets of molten or highly fractured rock that do not align with known geological models. Mount Lee continues to hum deep beneath the surface, sending subtle vibrations that no one has fully explained. The case of the disappearing lakes. Alaska's vast wilderness is dotted with countless lakes, many formed by glaciers or tectonic activity. Yet, some of these lakes have baffled scientists by vanishing seemingly overnight, leaving dry basins where deep water once lay. These disappearing lakes are not the result of seasonal droughts or evaporation. Their waters often vanish, without any warning or gradual decline, confounding researchers and locals alike. The phenomenon was first noted in the 1960s when aerial surveys revealed a series of lakes in the interior region that had suddenly disappeared between flights. Survey teams returned to the areas, expecting to find drainage channels or cracks in the ground. But many of the basins appeared untouched. No sediment movement or obvious erosion could explain how millions of gallons of water could vanish without a trace. Geologists initially considered underground drainage as a possible explanation. Some lakes sit at top-cast formations, areas of soluble rock like limestone where underground channels can carry water away. However, many of the disappearing lakes lie in regions without significant karst features, leaving scientists without a clear mechanism for their disappearance. Satellite imagery collected in the 1980s and 1990s provided further intrigue. In several cases, lakes that had vanished reappeared years later, sometimes in slightly different locations or with irregular shapes. This suggested that the water was not permanently lost, but temporarily relocated underground or stored in unknown reservoirs. The patterns of disappearance and reappearance defied conventional understanding of hydrology in cold glaciated regions. Local communities have long told stories of lakes that move or vanish in the dead of night. Elders recount observing waters that once teemed with fish and wildlife suddenly receding, leaving the shorelines cracked and empty. While folklore cannot serve as scientific evidence, these accounts often align with documented cases, hinting at a phenomenon that has been occurring for generations. In 2003, a research team led by Dr. Karen Finley used ground-penetrating radar to investigate a disappearing lake in the Yukon-Koyuk region. The radar scans revealed unusual subsurface cavities beneath the lake bed, some filled with water and others empty. The formation and connectivity of these cavities did not match known geological processes, suggesting that the lakes might drain into hidden channels or voids, whose existence is otherwise undetectable. Subsequent sonar mapping revealed that some of the cavities extended for hundreds of meters, forming complex underground networks. Water samples from these voids showed unusual concentrations of dissolved gases, suggesting chemical reactions might play a role in the drainage process. Temperature sensors detected subtle fluctuations that coincided with the lake's disappearance, hinting at dynamic subsurface conditions. Moreover, traces of previously unknown microbial life were discovered in the underground channels, raising questions about how these organisms survive in isolated, shifting aquatic environments. Hydrological studies have also measured chemical changes in nearby streams and groundwater after a lake disappears. In some cases, sudden increases in mineral content and temperature were recorded, indicating that water may flow into subterranean passages while interacting with geological layers previously unaccounted for. These observations far complicate the explanation for the disappearing lakes, as they show that the water's disappearance is accompanied by detectable changes underground. Some measurements showed sudden spikes in dissolved carbonates, which could indicate previously unknown subterranean mineral reactions affecting the water's movement. In certain locations, faint acoustic signals were detected underground, hinting that water might be flowing through hidden channels at speeds faster than expected. Climate does not appear to be a consistent factor. Disappearances occur during both wet and dry periods, and even lakes fed by constant glacial runoff can vanish in ways that defy expectation. This unpredictability makes it nearly impossible to forecast when or where the next lake will disappear, frustrating both scientists and local communities who depend on the lakes for fishing and water supply. Attempts to replicate the phenomenon in controlled experiments have failed, while small-scale, Drainage events can be simulated with permeable soil or hidden channels. The speed and scale of real disappearances remain unmatched. The sheer volume of water, sometimes millions of cubic meters, moves too quickly for any known underground process to account for it fully. The disappearing lakes of Alaska continue to confound observers, their waters vanishing without explanation and hinting at hidden forces beneath the landscape. The vanishing deep-sea vents of the illusions. Under the turbulent illusion waves, hydrothermal vents whisper of a strange and unforgiving realm unlike anything seen on the surface. These vents, located along the illusion ridge, emit superheated water rich with minerals and chemicals, supporting unique ecosystems that thrive in darkness and crushing pressure. Scientists have studied these vents for decades, marveling at the diversity of life they sustain, from giant tube worms to unusual crustaceans. But some events have begun to vanish in ways that defy explanation. The first documented observations of disappearing vents came from expeditions in the 1980s. Researchers, using submersibles, noted that vents active during one voyage would sometimes be completely inactive or missing entirely on return visits. The structures themselves, often made of mineral deposits built over decades, seem to vanish without any signs of collapse or erosion. These sudden disappearances left marine biologists and geologists struggling to understand what forces could remove such massive formations so quickly. During a 1992 survey, a team led by Dr. Richard von Herzen returned to a vent field that had been studied 5 years earlier. They found that several vents had ceased emitting water while others had disappeared entirely. Some vents appeared to have moved to nearby locations, forming new chimneys just meters away from where they once stood. This movement was not gradual. It seemed almost instantaneous, baffling the team and prompting questions about whether unseen geological processes were at work. Scientists initially suspected volcanic activity might be responsible. The Aleutian Ridge is tectonically active and underwater eruptions can reshape the seafloor. Yet in many cases, there was no evidence of lava flows, earthquakes, or other disturbances that could account for the disappearance. Seismic records showed only minor activity during the times the vents vanished out, far too small to explain the sudden removal of mineral structures and the cessation of chemical emissions. Chemical analysis of water around the missing vents added another layer of mystery. Concentrations of hydrogen sulfide, methane, and other vent-related compounds often remained elevated even after the vents were gone. This suggested that the heat and chemicals were still being released somewhere underground. Yet no physical vent structure could be found at the location. The water chemistry implied that a hidden conduit or subterranean system might be transporting fluids far from the original site. But mapping such systems at these depths is extremely challenging. Observations by remote-operated vehicles, ROVs, have captured strange patterns near vent fields. Clouds of minerals sometimes swirl as if stirred by strong currents. But the currents observed are not strong enough to account for the scale of vent. Disappearance video footage has shown vents that were active during one dive, completely replaced by bare rock formations on the next. Marine biologists note that organisms dependent on vent activity, such as chemosynthetic bacteria, often remain for weeks or months after the structures vanish, raising questions about how life persists when the source of their energy seems to have disappeared. In 2005, a survey by the research vessel Thomas G. Thompson documented one vent field that vanished almost entirely within 2 years. Hydrothermal fluid measurements indicated that high-pressure channels beneath the seafloor were still present, suggesting that the mineral deposits themselves were moving or dissolving rather than the fluid sources stopping entirely. Geologists have proposed that unknown subsea processes such as shifting magma, pockets, or rapid chemical reactions could be responsible for dissolving vent structures. But no model fully explains the sudden and repeated disappearances. Temperature anomalies add to the mystery. Sensors near disappearing vents often detect small but significant changes in heat distribution across the seafloor. These anomalies sometimes appear km away from the original vent site, suggesting that heat and fluids are traveling through subterranean channels that remain invisible to current mapping technology. The movement of heat without visible conduits challenges conventional understanding of fluid dynamics and mineral stability at such depths. The vanishing vents have consequences for local ecosystems as well. Species uniquely adapted to the extreme chemical environment must migrate or die when their vent disappears. Yet, some vent communities seem to survive, finding temporary refuge in surrounding microhabitats or even moving with the vent itself if it reappears nearby. This adaptability adds another layer of complexity as scientists attempt to understand not only the geological processes, but also the resilience of life in such extreme conditions. Despite decades of observation, the deep-sea vents of the Aleutians continue to appear and disappear without a clear explanation, hinting at hidden forces shaping the ocean floor and life above it. The vanishing icebergs of Prince William Sound. Music. Amid the stunning glaciers and floating icebergs of Prince William Sound, unusual events have quietly captured attention over the past few decades. Satellites and aerial surveys have occasionally recorded massive icebergs appearing suddenly in the waters, only for them to vanish without a trace. Unlike typical icebergs, which drift slowly and gradually melt over time, these disappearances are abrupt, leaving no visible debris or melting evidence. The phenomenon was first noticed in the late 1980s when a series of aerial photographs showed icebergs in positions that could not be explained by known currents. Researchers from the University of Alaska Fairbanks began tracking these anomalies using satellite imagery and boat-based observations. They noted that some icebergs measuring hundreds of meters across would be present one day and completely absent the next. The rapid disappearance challenges conventional understanding of glacier carving, ocean currents, and iceberg melt rates in cold Arctic waters. Observers have documented icebergs vanishing in calm weather conditions, which rules out sudden storms or extreme winds as the cause. In one notable instance, a research team aboard the vessel Professor Kromov recorded a massive iceberg near the Columbia Glacier that disappeared within 24 hours despite air temperatures remaining below freezing. The satellite images and on-site measurements confirmed that no significant fragments were left behind. Scientists are baffled, as even smaller icebergs usually leave visible remnants or signs of rapid melting. Some theories suggest that underwater currents or hidden channels may carry the icebergs out of sight. Yet, sonar mapping of the fjords has not revealed any such passageways large enough to accommodate massive icebergs. Oceanographers also considered the possibility of sublimation, where ice transitions directly to water vapor. But the rates observed in Prince William Sound cannot account for the complete disappearance of these enormous masses. The exact mechanism behind these vanishing icebergs remains unknown. Recent thermal imaging detected slight temperature anomalies in areas where icebergs later disappeared, hinting at underwater activity or currents not yet mapped. In addition, drone footage recorded faint bubbles rising from the water in the same locations, suggesting possible geothermal or gas-related influences on the iceberg's sudden vanishing. Further complicating the mystery is the apparent randomness of the events. Icebergs can vanish at any time of year under varying weather conditions and without any visible pattern. In 1995, A team of glaciologists observed 3 large icebergs near the Whittier Glacier melt completely within a single week, while other nearby icebergs remained intact. Attempts to predict which icebergs might vanish have consistently failed, emphasizing the unpredictability of the phenomenon. Local fishermen and tour operators have also reported unusual occurrences connected to these disappearing icebergs. Some recall strange water currents or shifts in ocean temperature shortly before an iceberg vanishes. Others have reported faint, deep underwater noises or vibrations, which scientists have not yet been able to explain. These anecdotal accounts suggest that the vanishing may involve forces or processes occurring below the water's surface beyond current technological observation. In addition to physical disappearance, some icebergs seem to change in composition before vanishing. Observers have noted ice that appears darker or denser than typical glacial ice, leading to speculation about unknown mineral deposits or trapped sediments influencing the iceberg's stability. Research teams have collected samples when possible, but no consistent chemical pattern has been identified, leaving the unusual density unexplained. Satellite technology has provided further insights, but also deepened the mystery. High-resolution images show icebergs disappearing in ways that do not align with surface currents, wind, or tide patterns. Even the largest icebergs weighing thousands of tons can vanish from one satellite path to the next. Some researchers propose that there may be underwater fractures or cavities that can absorb large ice masses, though no such structures have been conclusively detected. The vanishing icebergs of Prince William Sound pose questions not only about glacial behavior, but also about broader oceanographic processes. Scientists have yet to reconcile these events with existing models of iceberg drift, melting, and sublimation. Every observation seems to challenge assumptions about the stability and movement of large ice masses in cold waters, leaving even experienced glaciologists perplexed. Despite extensive monitoring and analysis, the mystery remains unresolved, drawing attention from researchers worldwide. The mystery of the Alaska fire rain. Alaska is known for its harsh weather with heavy snowfalls, fierce winds, and sudden storms. But there are rare occasions when something far stranger occurs. Residents of remote villages and even scientists stationed at observatories have reported rain that appears to ignite on contact with the ground. This phenomenon, often referred to as fire rain, has been documented intermittently since the early 20th century, though reports are few and widely scattered. Witnesses describe the raindrops as glowing with a reddish-orange light and producing small bursts of heat upon striking surfaces, leaving scorch marks in some cases. The first well-documented report came from Nome in 1923. Locals observed a brief but intense rain that seemed to flicker like sparks across rooftops and frozen ponds. At the time, meteorologists were baffled, recording normal atmospheric conditions with no evidence of lightning or volcanic activity. Scientists later speculated that unusual chemical reactions in the atmosphere could be responsible, but no laboratory experiment has successfully replicated the exact effect. Eyewitness accounts suggest that fire rain often occurs in the late afternoon or evening when the sun is low on the horizon. Some observers noted a faint smell of sulfur or ozone in the air, hinting at chemical or electrical activity high above the clouds. The rain does not behave like ordinary precipitation. It seems to fall in irregular bursts, often accompanied by flashes of light that are unlike typical lightning. Locals have recounted seeing drops bounce off surfaces before disintegrating, leaving small scorch marks that can linger for hours. More recent observations have come from the Kenai Peninsula and the areas near Fairbanks. In 1987, a group of geologists on an expedition recorded video of glowing droplets falling across a frozen river. They reported that instruments designed to measure Temperature and electrical charge detected brief spikes, coinciding with each glowing drop. Despite these measurements, no conclusive explanation has been found. The chemical composition of the rain remains undetermined because samples are nearly impossible to collect before the drops evaporate, burn, or disperse. Scientists have considered several potential causes. Some believe that meteoric dust or micrometeorites entering the atmosphere could ignite upon friction with air, creating tiny glowing raindrops. Others suggest electrical discharges from unusual atmospheric conditions may excite certain particles, causing them to emit light and heat as they fall. Volcanic ash or gases could also react with moisture in the air to produce brief combustion effects. But these theories fail to explain reports in areas far from volcanic activity. Local folklore adds another layer to the mystery. In some native Alaskan traditions, fire rain is said to be a warning from the spirits of the land, an omen of change or danger. Elders recount stories passed down through generations of glowing rain falling during times of upheaval or before significant events. While these stories are anecdotal, they align with documented observations, suggesting that the phenomenon has been occurring for centuries. Research teams attempting to study fire rain in the 2000s faced numerous challenges. The unpredictability of the events, combined with harsh weather and remote locations, makes field studies extremely difficult. High-speed cameras and temperature sensors have captured some of the bursts of light and heat. Yet, the underlying cause remains elusive. Atmospheric chemists note that unusual combinations of humidity, temperature, and particulate matter may create the effect. But no experiment has perfectly replicated the natural occurrence. Interestingly, fire rain sometimes appears in conjunction with other atmospheric phenomena. Witnesses report seeing unusual auroras, sudden electrical discharges, or strange cloud formations at the same time as the glowing raindrops. These correlations hint at an interaction between atmospheric electricity, particulate matter, and perhaps even geomagnetic forces, but no model fully explains the relationship. The randomness of the events makes it difficult to predict or study them in a controlled manner. Field scientists have also noted minor but consistent environmental traces. Soil and surfaces affected by fire rain sometimes show slight chemical changes, including oxidized minerals and traces of unusual compounds. These chemical signatures suggest that the rain is more than a visual phenomenon, interacting physically with the environment in ways that are not yet understood. Equipment placed in suspected fire rain zones occasionally registers brief surges of heat and voltage, further complicating the search for a conventional explanation. The mystery of the Alaska fire rain continues to defy science, occurring unpredictably and leaving both visual and chemical clues that challenge researchers' understanding of weather and atmospheric chemistry. The underwater booming structures of the Bering Sea. The frozen depths of the Bering Sea conceal structures that appear on sonar, puzzling even the most experienced oceanograpers. These formations, often dome-shaped and unusually large, emit low-frequency pulses that sound like distant booms when recorded underwater. First documented in the late 1990s, these booming structures appear in areas far from volcanic activity or known tectonic faults, making their existence a perplexing anomaly. While exploring the Aleutian Basin in 1998, researchers from the Woods Hole Oceanographic Institution stumbled upon massive dome-like structures rising from the ocean floor. The structures measured hundreds of meters across, yet repeated surveys failed to uncover any obvious geological source for the low-frequency signals. The pulses are rhythmic, sometimes lasting for several minutes, and they carry across vast distances, remaining detectable hundreds of kilos away. These sounds are unlike natural whale calls or known seismic activity. leading scientists to consider them entirely unexplained. The structures themselves are bizarre in appearance. Sonar images show smooth, almost perfectly rounded surfaces that rise sharply from the ocean floor. Unlike typical volcanic domes or hydrothermal vents, there are no visible chimneys, fissures, or magma deposits. In 2003, the submersible Alvin captured close-up images of one dome, revealing a surface that appeared to be covered in layered mineral deposits, but with no clear origin. Geologists have been unable to determine whether the formations are naturally occurring, or perhaps remnants of some unknown process beneath the seabed. The booming sounds emitted from the structures have unique acoustic characteristics. They are low in frequency, sometimes below 20 Hz, making them barely audible to human ears without specialized equipment. The pulses vary in intensity and timing, and their origin points seem to shift slightly between recordings, as if the sound source moves within the structure itself. Oceanographers note that such frequencies are highly unusual in shallow, sedimentary regions and are difficult to explain with known underwater processes. Attempts to sample the domes directly have revealed strange chemical properties in the surrounding water. Dissolved minerals in the area include unusual concentrations of sulfides, carbonates, and trace metals that do not match nearby seafloor sediments. Some researchers speculate that subterranean chemical reactions could be producing gases that resonate through the structures, creating the booming noises. However, no model has yet been able to fully account for both the chemical anomalies and the acoustic pulses at the same time. Several expeditions have recorded unusual patterns around the structures. Occasionally, sonar detects minor shifts in the dome's positions, suggesting movement or changes in the underlying sediment. Tiny plumes of particles sometimes rise from the surface of the domes, as if small bursts of pressure are being released. These observations are inconsistent and difficult to predict, frustrating attempts to study the phenomena systematically. Marine life around the booming structures adds to the mystery. Fish and invertebrates seem to avoid certain areas when the pulses are strongest. Yet large schools occasionally congregate near the edges of the domes. Biologists have documented changes in the behavior of deep-sea creatures during periods of strong pulsing, suggesting that the sounds may influence the local ecosystem. The connection between the booming noises and marine life remains largely unexplored, but it highlights the complex interaction between geology and biology in these unexplained areas. Historical records suggest that the booming sounds are not entirely new. Fishermen in the region have reported hearing unexplained underwater rumbles for decades, describing them as deep drums that seem to shake the hulls of vessels. These accounts align with the scientific recordings, indicating that the structures may have been active long before modern instruments documented them. Despite this, the lack of surface evidence or recognizable patterns makes them difficult to study or locate consistently. In 2010, a multi-institutional survey attempted to use seismic sensors and remotely operated vehicles to map the structures in greater detail. While the dome shapes and locations were confirmed, the sensors detected strange pressure waves and subtle vibrations that could not be traced to known geological activity. The findings suggested that the structures are part of a dynamic system, possibly involving unknown subsurface forces that transmit energy through the seabed and create the booming sounds. The underwater booming structures of the Bering Sea continue to intrigue scientists, producing sounds that echo through the depths and defy current understanding of ocean geology and chemistry. The submerged stone circles of the Gulf of Alaska. Deep beneath the cold waters of the Gulf of Alaska, researchers have discovered formations that defy simple explanation. Scattered across the ocean floor are stone circles so precise and uniform that geologists and marine archaeologists struggle to understand their origin. Each circle consists of stones, arranged in perfect symmetry with diameters ranging from 5 to 20 meters. Unlike random rock piles created by natural currents or ice movements, these formations exhibit deliberate spacing and alignment, suggesting a level of planning that seems impossible in such an environment. The first formal survey of these circles occurred in 2002 when the NOAA research vessel HEAL conducted high-resolution sonar mapping of the Gulf's continental shelf. Scientists has noticed unusual patterns that did not correspond to known geological processes. Follow-up dives revealed stones placed in almost perfect circular arrangements, sometimes with smaller stones forming concentric inner rings. Marine biologists and geologists were stunned because natural rock formations in similar oceanic conditions are rarely, if ever, so organized. Some stone circles appear isolated, while others are clustered in groups, forming patterns that span hundreds of meters. The placement of each stone appears intentional, yet no evidence of tools or human activity has been recovered in proximity to the formations. Even more puzzling is the uniformity of stone size and shape, which is difficult to account for with random currents, glacial deposits, or tidal action. These circles challenge researchers to reconsider assumptions about underwater landscapes and the forces that shape them. Analysis of the stones revealed unusual mineral traces absent from the nearby seabed, suggesting they may have originated from distant unknown places. Additionally, some circles contain stones that appear unusually smooth, as if polished deliberately, hinting at an unknown technique used in their placement. Diving expeditions led by Dr. Michael Kaufman in 2010 documented detailed measurements of several circles using underwater drones. The stones were rounded, smooth, and appeared deliberately positioned. Yet, there were no signs of recent human construction. Sediment layers around the stones suggest that some of the formations have existed for thousands of years, possibly predating recorded human activity in the region. Geologists cannot explain how such precise structures could survive centuries of underwater currents, earthquakes, and glacial shifts without being disrupted. Core samples taken from beneath the stones revealed sediment layers that show sudden shifts in deposition, indicating the circles may have survived unexpected underwater geological events. The mystery deepens when considering the location of some circles in areas with strong currents and uneven seabeds. Underwater landscapes in these regions are typically chaotic, shaped by glacial retreat and sediment flows. Yet the stone circles remain remarkably intact, as though they were anchored by forces beyond ordinary geology. Researchers have noted that some circles align with natural magnetic anomalies, though whether this is a coincidence or intentional is unknown. Submersible expeditions have revealed additional oddities. In some circles, stones appear to form geometric patterns beyond simple rings resembling rudimentary calendars or astronomical markers. These arrangements have led some to speculate about ancient civilizations or unknown cultures capable of precise underwater construction. Yet, no artifacts, pottery, or human remains have been found nearby, leaving the origin and purpose of the circles entirely unexplained. Marine life seems unusually abundant around the formations. Schools of fish, invertebrates, and even larger predators congregate within and around the circles, perhaps using them as natural shelters or hunting grounds. Scientists have begun to investigate whether these structures influence the local ecosystem in unexpected ways, providing both protection and a concentrated source of nutrients. However, number research has linked the marine activity directly to the construction of the circles, leaving ecological explanations incomplete. Remote sensing technology has added further intrigue. LiDAR and sonar scans show subtle depressions and raised features surrounding some circles, suggesting an interaction between the formations and the ocean floor over time. These features indicate that the circles may have been affected by changes in sea level, tectonic activity, or sediment deposition, yet they remain intact despite centuries of environmental stress. The combination of precision, durability, and location continues to baffle scientists. The submerged stone circles of the Gulf of Alaska continue to challenge conventional understanding of both natural and human-made structures. Every new survey raises more questions than answers, hinting at a past or process that remains hidden beneath the waves. The vanishing island in Bristol Bay. Off the coast of Alaska in the waters of Bristol Bay, satellite images have revealed a landmass that seems to defy explanation. At times, the island appears clearly with defined shorelines and patches of vegetation. On other occasions, it is completely gone, leaving only open water where the land should be. Scientists and photographers first noticed this phenomenon in the early 2000s when repeated satellite passes showed the island appearing and disappearing without any clear pattern or warning. Local fishermen have reported sightings of the island for decades, describing rocky outcrops and small sandbars that vanish after storms or even during calm weather. Some have claimed to set anchor near the island only to find it gone hours later, a phenomenon that has puzzled maritime authorities. Researchers have analyzed tidal patterns, currents, and sediment deposits in the area. Yet, none of these factors fully explain the island's sudden appearances and disappearances. The island itself appears modest in size, but its transient nature has made it a focal point for scientific inquiry. Drone surveys conducted in 2012 captured partial images of the landmass, showing low vegetation and small rock formations. Despite the visual evidence, repeated overflights sometimes failed to locate any trace of the island at all. Geologists initially suggested that shifting sediments or mudflats could account for the phenomenon, but sonar mapping has revealed solid ground beneath the surface, not soft, easily displaced silt. Bristol Bay is geologically active, with frequent earthquakes and glacial movements shaping the coastline. Some scientists have proposed that underground channels or rising and sinking land could temporarily lift or lower sections of the seabed, making the island visible or submerged at different times. Yet, measurements taken with precise GPS and sonar equipment show changes that are too sudden to be explained by slow geological processes alone. Historical records add another layer of mystery. Early explorers and Russian fur traders mapped the region in the 18th and 19th centuries, occasionally noting a small island in roughly the same location. These accounts, while vague, suggest that the island has been a recurring feature for hundreds of years. If it is the same landmass, then the phenomenon has persisted through centuries of environmental change, defying simple explanation. Underwater surveys have revealed unusual rock formations beneath the island that seem to resist erosion, a feature that may explain why the land occasionally resurfaces intact despite powerful currents. Some of these formations align with fault lines, hinting at a complex geological system that could lift or lower sections of the seabed without warning. Oceanographers have also detected pockets of trapped gas beneath the seabed, which may contribute to the island's disappearance. These gas pockets could create buoyant forces that temporarily raise the land, then collapse or disperse, causing the island to vanish once more. Marine biologists have also taken an interest as the intermittent exposure of the island affects local ecosystems. During periods when the island emerges, seabirds use it for nesting and fish aggregate around the newly exposed shorelines. When it disappears, the animals are forced to relocate, creating a cycle of ecological disruption that researchers are still studying. The interplay between the island and local wildlife hints at an intricate balance that has existed for an unknown period. Additional anomalies came to light in 2015, revealed through detailed satellite scans. The shape of the island can change slightly each time. It appears with new inlets or eroded edges that did not exist during previous sightings. This has led some to suggest that the phenomenon may involve more than simple submersion, possibly hinting at underwater currents or gas pockets shifting the seabed in unpredictable ways. Oceanographers are currently analyzing water density, temperature, and chemical composition in the region to determine if these factors could contribute to the island's vanishing act. Ancient tales from the area cast a shadow over the mystery, hinting at secrets long hidden in local law. Indigenous communities have long told stories of a land that appears and disappears in the bay, describing it as a place touched by spirits or governed by unseen forces. While these accounts cannot be scientifically verified, they align eerily with modern observations and suggest that the phenomenon has been noticed by humans for generations. Each time the island reappears, it raises more questions about the hidden forces at work beneath Bristol Bay. The electric sky flashes of the illusions. Over the Aleutian Islands, sailors and pilots have long reported seeing sudden bursts of light in the sky that defy explanation. Unlike conventional lightning, these flashes appear without storm clouds, sometimes illuminating the horizon in jagged patterns before vanishing as quickly as they appear. Witnesses describe the lights as intensely bright, often accompanied by a low humming or buzzing sound that seems to resonate through the air. Observers first documented these phenomena in detail during the 1960s when Air Force pilots flying routine missions over the islands noted their unpredictability and intensity. Residents have also reported unusual night skies with flashes of blue, white, and even violet light darting across the horizon. Fishermen in the surrounding waters often see these bursts reflected in the ocean, creating an eerie glow that seems to hover above the surface. Attempts to capture the phenomenon with early photographic equipment often failed as the flashes are brief and erratic, leaving little trace. Scientists initially suspected that these flashes were a form of atmospheric electricity, similar to upper atmosphere lightning called sprites. But observations did not match known patterns. Research in the 1970s and 1980s sought to investigate the flashes using radar and electromagnetic sensors. Data collected revealed that the burst emits strong electromagnetic pulses. Yet the origin of these pulses remained unexplained. Some pilots reported temporary malfunctions in aircraft instruments during sightings with compasses spinning wildly and radios cutting out entirely. These accounts suggested that the flashes may interact with electromagnetic fields in ways that modern science has yet to fully understand. Volcanic activity along the Aleutian chain adds another layer of complexity. The islands are part of the Pacific Ring of Fire, with numerous active volcanoes releasing gases and charged particles into the atmosphere. Some researchers propose that the electric sky flashes could be linked to volcanic emissions, interacting with atmospheric conditions. However, the flashes have also been observed in areas far from active volcanic sites, challenging the theory that eruptions are the sole cause. Oceanographers have noted that the flashes sometimes coincide with unusually strong magnetic anomalies over certain stretches of the Aleutians. Instruments on research vessels recorded brief spikes in the local magnetic field just as the sky lit up, suggesting a possible interaction between the Earth's magnetism and the electrical phenomenon. Researchers have also documented faint electrical discharges on the surface of the ocean beneath the flashes, creating ripples of light that last only a few seconds. These brief glows suggest a possible connection between the atmospheric phenomenon and the waters below, though no mechanism has been confirmed. Wildlife in the region also responds strangely to the bursts of light. Birds and marine mammals have been observed altering their behavior during the flashes with flocks changing direction, suddenly and schools of fish dispersing as if reacting to an unseen energy. These reactions indicate that the phenomenon may extend its influence beyond the atmosphere into the surrounding ecosystem. Sailors have reported that the flashes sometimes form geometric patterns with streaks crisscrossing the sky in grids or arcs. These formations can last for several seconds longer than a typical lightning strike before fading into darkness. Some have even suggested that the lights seem to respond to movement, appearing to track ships or aircraft as they pass through the area. While this remains anecdotal, repeated reports across decades hint at consistent, unexplained phenomenon that defies natural explanation. Meteorologists have also studied the flashes in relation to atmospheric pressure and wind currents. Observations indicate that the bursts often occur in regions where cold and warm air masses collide, but no consistent weather pattern has been identified. Researchers equipped ships with high-speed cameras and spectrometers in the early 2000s, hoping to analyze the composition and behavior of the light. Spectral analysis revealed unusual emissions in the ultraviolet range, further distinguishing these flashes from ordinary lightning or auroral phenomena. Naval records from the Cold War era show that the flashes sometimes interfered with radar and communications in the illusions, leading some military analysts to speculate on possible ionospheric effects. The bursts appeared over both remote islands and open waters with no predictable schedule. Scientific teams have monitored the region continuously, yet the flashes remain sporadic and enigmatic, eluding even the most sensitive instruments. The flashes continue to ignite the illusion sky, hinting at forces in the atmosphere that